Good morning, friends of class 10th. Today we will learn about a little more about the refraction of light, and we will take two different things over here today. One is a rectangular glass slab and other is a glass prism. Okay, so what is so special about the light when it passes through a rectangular glass slab? Okay, let us see this. First of all, you can see that we have a glass slab. This is the glass slab. Okay, the incident ray is called PQ. Okay, then the ray turns inwards in the glass. The ray becomes QR. Can you see this QR? This is the refracted ray, and the ray RS. RS is the emergent ray. Okay, now if the glass prism is removed from here, what will happen to the ray PQ? Instead of bending, the ray PQ will go like this along the dotted line. Okay, the dotted line shows the path that the ray will move if the glass slab is not there. But in presence of glass slab, this becomes angle of incidence. This is angle of refraction, I call it R1. This is another angle of incidence, but this time the ray of light is going from denser medium to rarer medium. Okay, going from rarer to denser, it bends towards the normal, and going from denser towards the rarer, again it bends, but this time it is bending away from the normal. So you can see R1 will be smaller than I, and angle of emergence will be greater than the angle of incidence R2. I am calling it R1 and R2 because both these angles lie within the glass slab. Okay, so what is something special that is happening in this? See, if the glass slab is not there, the ray will go straight, but if the glass slab is there, the ray will bend 2 times, and finally after emerging from the glass slab, the ray will shift parallel to itself. The ray will shift parallel to itself. This phenomena is known as lateral deviation. Okay, what is this known as? This is called as lateral shift, because the ray has shifted parallel to itself. See, the emergent ray and the would-be emergent ray, they are all parallel to each other. Now what is remarkable in this, what is something other facts to be noted is that angle R1 and angle R2 are equal. Why? Because they are alternate angles. Can you see that Z? This Z. Okay, so that makes R1 and R2 equal. Now because angle R1 and R2 are equal, angle I and angle E are also equal. That means angle of incidence is equals to angle of emergence. Alright, these two things are to be noted in refraction through a glass slab. Now what will happen to this lateral shift if I increase angle of incidence? If I increase angle of incidence, the lateral shift is also going to increase, because you can see if I increase the angle of incidence, what is going to happen to angle of emergence? They are equal. So if I increases, E also increases, and by this the lateral shift increases. Okay, the next thing to be learned is refraction through a glass prism. Okay, now this is a glass prism. The name is ABC. This is necessarily not an equilateral glass prism, because this is not an equilateral triangle. It can be of any other angle. The incident ray is PQ. The angle of incidence is I, you can see over there. Okay, then QR is what? It is the refracted ray. And RS is what? RS is the emergent ray. Okay, now see, I have marked some angles in this. This is angle I, angle of incidence. This is angle R1, the angle of refraction, when the ray of light is going from rarer to denser medium. Again, going from denser to rarer medium, angle of incidence is what? It is R2. And the last angle, which is actually angle of refraction for the second refraction, I am calling it as angle of emergence. Same way I had called it in the glass slab, same is over here. Okay, now see, if the prism is removed from here, if the prism is removed, then how would PQ travel? PQ would travel like this, straight. Okay, it would travel straight. But if prism is placed, then what will happen? The ray will be bending. So what is the total effect of placing the prism? It is that the ray PQ will deviate by its own path. This time it will not shift parallel to itself, but this time the deflection will be angular. Okay, prism will turn the incident ray through some angle, and that angle is angle of deviation, angle delta. This one is what? This one is the angle of deviation. Got it? Okay, how would you draw the angle of deviation? Extend the incident ray in forward direction. Listen again. Extend the incident ray in forward direction. Extend the emergent ray in backward direction. Okay, till they meet at some point. And at that point, you have to draw an angle between the would-be incident ray and the would-be emergent ray. Now that will be your angle of deviation. Okay, this phenomena is called angular deviation. In the glass prism, it was lateral shift. Now it is angular deviation. Now what is the mathematical fact of this deviation? You can see the equation I have written below. I plus E is equals to A plus delta. What is angle I? Angle of incidence. What is angle E? Angle of emergence. What is angle A? Angle A is the prism angle you can see at the top. Okay. See, you can see this angle. This is the angle. This angle I am talking about. Let me show you what that angle will be. This angle. This is angle A, and what is delta? Delta is the angle of deviation. So this fact is always present in the prism, whether it is an equilateral prism or a 90-degree prism or a 30-degree prism, whatever prism it is. But this mathematical relation is always found, that I plus E will be equal to A plus delta. Okay, what will be asked in the examination from this? Be prepared for objective questions. Okay, and the phenomena of lateral shift and lateral deviation.